This tutorial. This tutorial is done as a live streaming as well, so I hope that I can see some of your interaction through the chat. So what are we going to do today? We are going to do a basic example about how to set a multi-node aquifer well in Modflow 6 and model Muse. And for that we are going to take as a base one model that was previously done in another tutorial. So the link of the tutorial will be on the video, and then we can start from the output of the last tutorial in order to implement the multi-node aquifer well. Okay, that is the what that we are going to. I always this is MAW USGS. Yeah, USGS MAW USGS. The exact name is Multi Aquifer Well package. Okay, Multi Aquifer Well package. Okay, great. So let's start. We are going to start with. You are going to receive this on the description of the video. That is actually, this is the modeling. That is the output of the other tutorial. This is model out, where we are going to store the model. This is no, this is not this is a temporary file, and then when the results are going to be analyzed through Flopy, so we need some scripting in Flopy. And well, there is a shape file, but actually it's not required. So let's start. For this we need to start our model Muse, and then we are going to open an existing Modflow project, and then here we are going to you're going to open the model one here. Okay, let me check because okay, and then this is a steady state model that actually do not have any wells on that. Okay, and what we are needed to do is that we are going to insert on the model on time. We are going to insert 2 more times. We are going to work in seconds, and then we are going to insert two stress periods of 10 days. Yeah, that is 400,000. Yes, and the other will be, let me check, 178, 172,000, and these will be just analyzed every day, so we will have 10 time steps. And here as well we are going to have 10 time steps. Yeah, time steps. Okay, because we are going to have 2 stress periods of 10 days, and it will be divided in 10 time step each one. Okay, great. Yep, and then your store package have been activated. Yes, because this is on Modflow 6. The store package is activated once you define trends and boundary conditions. Okay, something that we have to, before setting up the multi-node aquifer well, we have to extend the dimension, the time or the duration of the boundary condition that actually, according to documentation, might not be explicitly required. However, it's always a nice it's a nice quality control to have this to have the boundary conditions on the whole extension of the model. Okay, so let's go here, for example, here Modflow. Let's go to the general head boundaries. So here model lake, each by, so instead of ending up at 0, it will end up at this time, and the regional flow, it will be end up this time. And the observation actually is not required for us or for the purpose of this tutorial. The recharge, yes, because, and the river package. Okay, so that will be okay. So we have extended the duration of the boundary conditions. Okay, close. Yep. And then we can insert our well. And where we are going to insert our well, we are going to insert it in this cell. Okay. Here in this cell. Okay. And this, how is going to be? This will be Multi Aquifer Well 1. We can change color here. And then it requires that it has 0 formulas, okay? Yes. And here we go to okay. So we have created the object, okay? We have created the object, but we haven't turned off the package. So we are going to the package boundary conditions, and here is the multi-node aquifer well. Let's have a look on that, because it has some special it has some parameters that are on the documentation, but maybe it will be helpful for you if you face some problems. First, you are going to print the heads on the listing file, okay? So you will have a listing file. It will print the heads on the list file, but it will also save the heads on a head file and the budget on a bud file, but as a binary, okay? And what does it mean? That the head on the well will be imprinted in the file, and also the budget of the well will be also printed on another file as a binary, and that's why we need to open that with Flopy, because Flopy can read those binary files, okay? And there is this include well storage. This is because in multi-node aquifer well you can count with the water that is inside the well, okay? Because when you start pumping, it doesn't mean that automatically you will start taking water from the aquifer, because your well has water, okay? However, I'm trying to go to the documentation to see how it works. Okay, this is the shutdown, theta and kappa, and these are kind of the relaxation factors for heads and for flows. And what does it mean? That in the normal well, if you are pumping like a great amount of water from the aquifer, and if you face some convergent some numerical problems, it will probably turn off. I mean, if you want to pump and then if the model do not find any convergence, what they will actually do is that it will dry the cell, and it will give you that the well cell is dry and there is no pumping on your model. However, this can be numerically. I mean, this can be done. I mean, maybe it's because your matrix is not so relaxed, okay? So these values are in order to relax your matrix in order to reach a solution, okay? And however, if your matrix will be so relaxed, you are not going to reach any convergence as well. So I left you one. This is for heads and this is for flows. You can play around with that if you are facing some problems, okay? Okay. Always remind that the pumping rate of a well is determined by the hydraulic conductivity, because it doesn't matter that you want to pump 50 liters per second. If the groundwater flow system gives you 5, the maximum that you can pump is 5. I mean, and then if you set 50 liters per second, it will dry your well. Okay, great. So now we can go to our well. Yeah. and then from our well we can go to multi-node aquifer well. The radius will be 1, the bottom will be the bottom of the model. Actually this can be also arbitrary, so you can put your model. And the starting head is model top. However, the first you have a first stress period on the steady state, so the initial water head, this is the chicken and the egg, because you have a starting head. However, on the first stress period, since the steady state, you will have the head on the well. Okay. Yeah, this is another discussion, but let's say that because we have a steady and then transient models, this is a right approach, because if you will have only transient models, you are required to insert here the current water table, the water level on your well. Okay, and the conductance will be time, and this is as well on the documentations, the different conductance types. Okay, in our case will be time. Okay, let's type. We are going to work in with three screens. The ones that go, the first one goes to model top, to upper aquifer bottom. The other ones will go to from upper aquifer bottom to middle aquifer bottom, and this goes from middle aquifer bottom to lower aquifer bottom. And since we have selected the time, actually these values are not required, so we are going to just to put any value here, but those won't be taken into the consideration. And here on transient, we have -0 to 0, 0 to active. Okay, and at the beginning there is pumping in this model. And then, but the pumping is small, and then we upgrade the pumping from 3 liters per second to 30 liters per second, and then on the last 10 days we increase it to 60 liters per second. Amazing. Okay, there are some limitations, rate limitation, head limits, and so on, and the multi-node aquifer well actually is well implemented in that. However, for us, we are not going to take this into consideration. Okay, we are not going to use it, but there are some conditionals there that are very interesting, and I think that those are more interesting if you want to calibrate a pumping test, or like if you want to represent the real dynamic of a pumping field. Okay, great. I think that this will be enough, so we can let's save as, and then we are going to save that in our model out. We are going to save as in our model out. Yes. Okay, so we have saved that in our model out, and then we can run our project. Okay, here we are facing some problems. Yeah. Yes. We face some problems here that were actually, let's see which kind of problems those are. Maybe there is too much pumping. Okay. Usually, let's see here in out, in the list file. I'm going to open this with Notepad, and then no, those are just convergence problems because it's pumping almost what we had at the beginning. Yes, I mean, this is a tutorial. I will go to the right procedure to do this is to go to the solver, or like trying to decrease. There are several ways, or trying to decrease the pumping rate, or going to the solver and increasing the amount of iterations. Okay, but we are not going to deal with this in this tutorial because this tutorial is mostly because it will take you maybe 20 minutes to do that. Okay, and in my draft model actually it works, so I have to see what I went wrong with that. Okay, I will do it I will try to do it solver EMS simple PCT. Yeah, I will use the network configuration. Okay, and let's see if with the neighbor configuration it works well. Now no, actually doesn't make. That's why I don't want to do this stuff live. Yeah, I will take out on the solvers, I will take out the network configuration. However, I will increase to 250. Okay, and this will be the last that I will do on this. Yeah, I have still this. Yeah, you can play around with that with the solver to see what went wrong there. Okay, and then we have, I think that affects this, the multi-node aquifer well. Okay, yeah. Okay, so, or yeah, I can do something else. What I can do is that it will be a lazy trick, but I will decrease the pumping on from here. I will increase it from 260 to 45. Okay, that's it. Okay, so let's see. Okay, great, amazing. Yeah, well, 60 maybe was too much. Okay, and here, okay, I have 45 liters. Yeah, and that's all right. Okay, let's start. Okay, so we can import the heads for the last part as a control grid. Why not? Yes, so here we have for the first layer, the second layer, and the third layer. We can also represent the cross section of the water table. Oops. Okay, great. But something that is more interesting than this is that we can actually get how much water comes to the pumping rate from each layer. Okay, so how is the percentage of how much is the percentage of flow that comes from each layer to the well? So let's do this with Anaconda Prom. So cd documents, okay, cd groundwater, okay, dir, okay, and then Jupyter Lab here, Jupyter Lab, okay. And then here we are going to have this. I have here a script that I will clear our outputs. Okay, first we require the import the required files, then we are going to open the heads, okay, and this case is model out. Okay, great. So here we have, and these are just the 5 heads, the times, but actually the times are much, I mean, are from the first second to the 10 days and 1 second, okay, but in this case I'm going just to show you the first ones. Okay, and then I'm going to get these are the times, and then I'm going to get the heads, but I am going to show you just the first ones. Okay, and then I can plot the times and the heads. So this will be the heads. This is at the beginning, then when it pumps 30 liters per second, and then when it pumps 45 liters per second. Okay, and this is the level on the head. Okay, that is actually something that is amazing on this is that if I go here, the head is almost the same on the well. Okay, and this is something that you are expected to see. Okay, so we have maybe 1 millimeter, of difference. Okay, and then yes, and this is something like that show you that the well is also pumping from all cells. Okay, and then I'm going to out, and then we are going to get the times model out. Sorry. Okay, great, and then we are going to, with that, this code is actually because it has 3 layers, okay, but in any case that you might need more layers, so maybe you have to tweak this code. Okay, I strongly recommend that you represent this tutorial, and then from that you go with your own and this is this with your own projects. Okay, and this is a numpy that show you the total pumping on the cells, and this goes from 3 liters to 29.84 liters, and then increases to 40, almost 45 liters. Okay, and then we can plot by layer, and we are going to see something that is very interesting. Okay, this is the total pumping. The first layer has this, and maybe it's the most important, how we say, this is the most important source to pumping. Okay, maybe might be 2 reasons. Maybe because this is the most unconfined layer, but if you see layer 2 in comparison with layer 3, layer 2 has really limited relevance on pumping. And why? Because if you go to the if you go to the model, and then if we plot the kx, we see that the second layer has maybe 1 order of magnitude less hydraulic conductivity than the first layer. Okay, and it's a half of the it's 1/4 of the 4th layer. So that's why when you saw this, is really limited how much water from pumping come from the second layer. Okay, and this is amazing. I mean, we can even do some analysis of the confined and unconfined source of pumping, but because it is listed here on the or we can show you this. It's listed model out on the model 1 list, if we go to the bottom, yeah, so we have the storage from the SS that actually comes from here, but in our model, let's say our model datasets and cell type, yeah, because our model is not is confined by default. Okay, so we have to, yeah, I'm not going to do this here because actually I can find another convergence problems. Okay, but you can type, you can see how will be the impact of setting the cell type as convertible. Okay, first if it runs, and the second how it will affect the how will it affect the the distribution of sources, yeah, how it will affect this. And third, that you can also plot how much water comes from the confined part and the unconfined part. Okay, I see that at the end of this live streaming there are 5 people watching this streaming, so thank you for being to watch our tutorials. We have around 6,000 subscribers or maybe more, but our goal is to reach 10,000 subscribers because we want to make our blog bigger, and we want that more people will reach our tutorials. So if you haven't subscribed, please subscribe to our YouTube channel. All the models will be on the description of this video, and I hope that you like it, and see you in coming tutorials. So have a great day, and see you and have a great day. Bye bye.